Hi, my name's Jeff Nepper. Thank you for joining me today as we discuss information management and particularly focus around architecture that will help manufacturers and utilities expand and govern the process of going from raw data into valuable information. Let's talk about how we have processed data into information for the last 30 years inside of the manufacturing and utility spaces. If we think about our organization as a series of data producers or data silos, places where data is being generated or where data is already stored, and we can also think about all of the different people and applications and things across our organization that want to consume that data. When it's time to consume that data, we for 30 years have taken the application of choice, connected it to the archives, and then started to do the data transformation process. And that process has looked the same. It is connecting and ingesting, cleansing, contextualizing, identifying events, aggregating KPIs, validating results, and then distributing that information. And typically, we distribute that information in the form of a widget or a chart on a report. Now, there's been a problem, though, with the way that we've done this. And it's not in the steps that we've done it, it's where we store this work. So the process of connecting and cleansing, identifying events, aggregating KPIs, all of that work is code intense and has been buried inside of that application. And it's not just one application that we use, it's many different applications, multiple versions of those applications spread across the entire enterprise. And every group of subject matter experts has their applications of choice. And we continue to do this process over and over again at the application layer. So by distributing our data transformations, we have essentially created infrastructure that we can't manage or govern. It's heavy in code. It's very expensive, both in time and in cost of execution, and it simply doesn't scale. Now, in the recent few years, some new architectures has arisen, and that architecture includes a unified namespace. A unified namespace is a broker in the middle of our data producers and our data consumers. And both the producer and the consumer can publish and subscribe their data feeds to that broker. So we get a very nice unified architecture with a broker in the middle. But there's some roadblocks here. First, most of these older technologies don't support the technologies that we're using for our unified namespace. That is to say, we need to do some protocol translations. We need to take data that's in a SQL database and figure out how to stream it to a unified namespace. We need to take data that's in a historian and figure out how to make it publish on change to a unified namespace. So that requires middleware or new subscriptions or new licenses and a good amount of integration work to make that happen. The next roadblock is that this is really focused on just real-time data. I'm only ever going to know about the most recent data point by subscribing to the unified namespace. So what about my application that needs history? My BI tool that wants to understand what the values have been for the last 48 hours. Well, those applications will then have to connect back to the source. And when we do that, we lose our hub-spoke architecture and we move back to a point-to-point integration. Well, where does the work live for processing raw data and turning it into information? It can't live in the UNS. There's not a capability for it to live there. So just like we have for 30 years, we tend to then take this process and bury it inside of the applications itself. So now when I step back and look at this architecture, I'm seeing, yes, I am transforming part of my architecture into a hub-spoke model with the real-time data values. But when it comes to being able to get history and being able to right process on how I transform data into information, I'm really still in an older architecture at this point. And there is a final flag here. Now that I have some new insights, how do I get them back to the UNS? Again, I will probably have to require some integration and some middleware. So what about a different architecture? What if we tried to solve the historical access problem and the information management problem, that is, centralize the process of transforming data? That's where the data lake architecture comes into play. So with my UNS in place, I could subscribe from the data lake and rehistorize all of the data that is currently stored in my other applications. Now, a potential roadblock here is that I am duplicating work that's already been performed, meaning I've already got validated archives of this data stored, and I am going to duplicate that. But we could make the argument that duplication means accessibility. So assuming that I have duplicated all of my archives into a data lake, now I could say the process of transforming raw data into information will be the responsibility of my enterprise data teams. They have an entire suite of tools that they can use to facilitate those transformations, and this process will live and be governed here at the data lake or the data warehouse. There is one problem here, is that I have really focused this work on my enterprise data teams, and I have left out a crucial group of individuals from across my organization, and that's my OT teams and my engineers. It's absolutely imperative that they be part of this process because they have all of the knowledge of what the data means that I'm replicating from these archives. Also, they're one of the #1 consumers of this information. They have the capability of quickly affecting process with the right insights. So how do I ensure that my OT teams and my engineers are part of this data transformation process, that they are helping to contextualize the data and describe the KPIs and the events that they care about? Well, I can't really just connect them to the database because they're not comfortable or skilled in all of the tool sets that my enterprise data teams are, where my enterprise data teams are used to using Snowflake or Qlik or BigQuery. My OT teams and my engineers, the tools that they're most comfortable with are trending tools and Excel. So without being able to give them a way to work within my data infrastructure, I'm really going to miss out and lose on the context that they know and the knowledge that they have of this data at the site. Moving on to another potential roadblock, now that I've made my data lake my hub, how do I ensure that not just my enterprise applications, but my site-based applications and my OT teams can communicate and interact with that data? Well, typically, the only way to make this happen is to build a secondary team that we call the reporting factory. And that team sits with one customer, and that is the site. And the site makes requests to the team for information, and then this reporting team provides that information to the site. A few problems here is that this does not promote OT-level citizen development. This is not a self-serve architecture. Instead, my OT teams are now relying on other teams to meet their needs. If those teams are slow in response or provide bad data, after just a few sessions, the OT teams will stop making those requests. They will remember that they have a tool that they're very versed at using, and they will also remember that the data that they are looking for is very close, sitting at the site, and they know how to access it. As soon as this workflow changes and they begin to self-serve from their own archives, we lose our governance, we lose the context, we lose the scalability. Okay, so how do we solve this problem? Well, to solve this problem, we take what is working in the unified namespace and we expand upon it. So the unified namespace has shown us that it's great for real-time data. I can connect my OPC servers, my gateways, my MQTT brokers. I can put middleware where necessary, and I can subscribe to that data from the enterprise for things like my data lake or a Kafka stream, or maybe even a report or two that focuses on real-time data. If I wanted to then expand this architecture and maintain a broker-centric hub-spoke model, but incorporate the archives of historic data, I do so with a unified analytic framework. A unified analytic framework is complementary to a unified namespace, but rather than focusing on real-time data, the focus on the unified analytic framework is incorporating all of the rich history of data that an organization has. So by having access to the history, now we can ask ourselves the question of where does the model of how to turn the data into information live? Where before it was getting buried inside of the applications or living on top of a data lake that my OT teams could not collaborate with the unified analytic framework, the focus is to centralize this work and pick up the insights from OT. And this is crucial as a benefit of a UAF architecture. So with both enterprise and OT collaborating around what events do we care about? What is the context of this data mean? What are the KPIs that we need to calculate? How do we cleanse the data before we do that? With that information defined at the central part of the organization, that is where the OT and the IT space are converging, now we need a series of engines that will execute the rules and transform that data 24/7. Inside of the UAF, the second key focus is those engines. So those engines are constantly watching for events, calculating KPIs, publishing the results into a UAF database, as well as back to the unified namespace and to all of the applications that require KPIs and events. That data is cleansed, it's processed, it's stored, and it's ready to use. Finally, that means I have a single place to focus my governance. I can always look to the UAF to understand the rules around the expressions and the events that we care about. I can look to the UAF for a full audit log of what has changed and why, what were the versions of these KPIs, and finally, I can create a self-service hub for raw data for my entire organization. So real-time data is coming from the UNS, but what if the data teams look over to some series of site databases like historians or LIMS and quality systems, and they need raw data from those systems? The UAF becomes a registry of all databases that are connected to it. And that means through an API, the data teams can query the UAF and say, you know about this data because it is in data systems that are connected to you. Get 30 days of raw data from the historian or from the LIMS system on this site. And without the data teams having to understand how to interact with the historian or the SQL database, the UAF can query those systems, extract the raw data, and then provide one easy to work with normalized payload to that data team. This is the advantage of a solid information management strategy. It's not just about real-time data. It's about how do I take that data and transform it into information and make it available to my organization. This is exactly what Flow seeks to do. And it's really a use case-based deployment strategy so that on the next data project, you begin building your UAF. That means whether you're looking to perform a scrap prevention or a utility consumption use case, batch reporting, quality assurance, cost monitoring, or chasing OEE. This is a great way to begin building out your UAF because each of these different projects will build off of the other. If I'm doing scrap prevention, I am already setting a foundation to also then begin building out OEE calcs. If I'm focused on cost monitoring, utility consumption is going to be important. If I'm looking for asset management and maintenance, I might as well also be tracking downtime and categorizing my reasons for downtime. So by continuing to build all of my data projects on top of a UAF architecture, I'm ensuring strong governance, the incorporation of my OT and engineering teams, and I am taking the work from every data project that I do and continuing to expand it while creating infrastructure for accessing historic information across my entire organization.